Hello everyone and welcome to session 1 of week 9. In this session what we're going to look at is health information systems, and we're going to give you an overview first of all of what is an information system, and then we're going to relate this concept to how it applies to health information systems. So these are the objectives for the week. So the presentation will be done in 2 short parts. Firstly, we're going to describe and discuss the key features of information systems in general. So let's start with a question. When we think about information systems, there are a number of features that make up that information system. What do you think are the key features of any information system? Take some time to think about this, perhaps jot down some ideas. And as we listen to the rest of the presentation and we address the different key features, see if any of the things that you've mentioned come up. So to start off with, let's think about some of the work we did in week 8 around information and models. And let's link this to the idea of an information system. So systems are important. We can ask, what do systems do? Systems help us to organize the ways that we work. And in this way, systems are models that provide a template for the actions that we want to produce in the world. A system is seen as a set of interacting components, processes, or objects. If we think back to Health System Science 1, we looked at some of the component parts of a health system. We looked at them in isolation: human resources, financing, policy, medicines and technologies. But what's important is to see how those different component parts interact. And it's within those different interactions that we see the complexity within a system. So there's a relationship between the construct of a model and how a system works. So systems can be thought of in 3 different ways in relation to models. So the model could be acting as an abstracted description of a set of objects or processes observed in the real world. So if we think of the health system, someone's description of how they see the health system is based upon their observation of the world. The system can also be seen as a model consisting of several interlinked elements acting as a template of action. So let's think about a proposal or a plan for how health should work. Perhaps a policy that is trying to be implemented within the health system. We have to think about many different component parts that would have to be drawn together to make that policy successful. It would have to be financed. We would need to have people in place. We would need to have people trained. We would need to have medicines and technologies available in order for that policy to be properly implemented. We can also think of a system as an artifact constructed by the process of instantiating such a template in the real world. So let's think about this in terms of the physical collection that makes up a health system. We can think about people, buildings and infrastructure that collectively come together to deliver healthcare. So there are a number of features within health information systems, or within information systems more generally. Systems have a set of inputs which are transformed by the components of the system into a set of outputs. And in the process of transforming those inputs into outputs, we see that there is often a state of change within the system. Let's think about this in terms of work we've done in Module 2 around structure, process, and outcome. So the inputs can be seen as structural measures that have to be put in place. We need to have medicines, people in place. We need to have a certain number of beds. And if a person was to enter into the system, there will be different processes that would be followed depending on the needs of that person. So for example, if they need to have certain tests done, for example, a blood test taken, there will be a process that is followed within the system. The bloods will be drawn, they'll be sent to the lab, and that will therefore lead to a particular output, which will help, for example, a clinician make a decision around that patient's needs. Perhaps a simpler way of describing inputs and processes and outputs. Let's think about this in relation to making a cup of coffee. You would need to have certain inputs before you can make that coffee. So before it goes into the machine, which would be the system, you would need to have coffee beans, you would need to have water, and you'd need to have heat. So once you put those things together, that will then create the output that you're looking for, which would be a hot cup of coffee. So we can see in that way that the inputs will then change to form something else. So the coffee beans become liquid coffee. Another feature of a system is that it is distinguishable from its environment, and it should have a characteristic behavior. It needs to act in a particular way. So that's why we can talk about an education system or a health system. There's certain characteristics that distinguish those systems from each other. Of course, there will be things that are similar, but there's definitely specific things that need to be in place that create that system. So a system's behavior cannot usually be predicted by an examination of its individual components, as it emerges out of the way that those components interact with each other. So there's all these different inputs or different things that need to be put in place, but the behavior of that system is a result of how those different component parts interact. Systems are embedded within an environment, right? So our health system does not exist in isolation. It exists within a bigger environment. And therefore, there must be a boundary between the system and the rest of the environment in order to distinguish what makes this a discrete system that works by itself. So depending on how discrete those boundaries are, we have different types of systems. And I'm sure this work you covered in HSD in first year. So some systems are closed. Other systems are relatively closed, so the boundaries are a little bit more porous. And some systems are open. So closed systems have no external inputs and outputs. So everything happens within that system, within the boundaries of that system. Whereas relatively closed systems have very precisely defined inputs that allow for very precisely defined outputs within a clear and distinguishable environment. Whereas an open system would interact a lot more freely with that surrounding environment. So the boundaries around that system would be much more porous. I'm hoping that some of these ideas are familiar. Some further features of information systems is that systems have an internal structure, because a system's overall behavior arises out of the behavior of its parts. So these component parts of a system are often broken up into subsystems. For example, if we think about our health system, it can be broken up into different levels of care. You might have a community health system within the community versus services available at a hospital. And if you were to go to a hospital, you'll see that within that hospital, there are different departments, right? So things within the internal structure of a hospital will look different to the internal structure of a community health center. There might be some similarities because they are operating within a bigger system, but there will also be subcomponents that are particular to that system. So for a system to function, each of its subsystems or components have to interact and they need to communicate. Let's think about this in terms of referral between primary levels of care, secondary levels of care, tertiary levels of care. So how do we move people from a community health center to a hospital, we need to be able to communicate what has happened within one subsystem to another subsystem. So this means that they often share similar inputs and similar outputs, right? So we will have similar inputs in different subsystems. We'll have similarly trained professionals, but we might have slight differences between the different levels of care. And essentially the output, what are we trying to achieve? We're trying to achieve improved health outcomes. So within any system, we also have different types of feedback, which allows us to see whether what we are trying to achieve is being achieved or not. So simple feedback control systems have three components, and I'm sure this is also familiar to you. There might be a sensor, a comparator, and an activator. So a sensor measures the parameters that can be controlled, so we know what can be controlled within a system, whereas the comparator determines whether the measurement deviates from that desired range, right? And the activator creates an output which then alters the environment in some way to change the value of the parameter being measured. I think a simple example explains this much better than thinking about these as sensors, comparators, and activators. Let's think about a thermostat, which is a device that controls temperature. So we would set the temperature for something to be the ideal temperature, right? And a thermostat would then act as part of a feedback system for controlling that temperature. So the thermostat will sample the temperature, for example, of a room that is being warmed by a heating system. And as that temperature rises, the system will shut off when the determined temperature is reached. And then if the temperature decreases, there will be an internal process which will then activate the thermostat again, right? So when it reaches set point, the thermostat will turn on again. So you can see that within systems, there's certain control measures that are put in place. We know that systems can be described as arbitrary, right? So let's think about the discussion we had last week about maps. We know that the map is not really a true picture of the reality it's describing, but that map has a very distinct purpose. And a very key feature of an information system is that it functions with a distinct purpose in mind. So we can see that there is a relationship between information systems, between data and between models. So an information system is formed when decisions are made on a regular basis that require access to the same kind of data and that may use the same kind of knowledge. So an information system could be the way, for example, the way that a triage nurse will be assessing patients on arrival in an emergency department. They will have a triage scale that will be used every single time a person walks into an emergency department. And the same processes will be followed. So information systems need to be distinguished from other systems by the components within that system, which include the data that we are collecting and the models that we are using to interpret that data. So there are many potential internal components that could be included within an information system, including a database where we have different points of data being collected, a knowledge base, for example, how we will interpret that data into points of information and apply that to a knowledge base, or as we discussed last week, an ontology, or decision procedures or rules of inference. So the different components of an information system are connected together with input and output channels, which allow data to be shifted between different components as we might need them. For any information system to work, we need to pick out decisions, data, and models that are in some way consistent as a group, that is of interest for the purpose of that system, and then look upon them collectively as one system. So each information system exists within an environment and is usually built with a purpose to interact in a particular way with that environment. If we think about how an information system might collect data points in one setting and the same data points in a different setting, what is important is to consider the environment in which the data is being collected, because that will affect that could be affected by the inputs, what is available within that system, and that will therefore affect what the outputs are. So we will see that there might be two very different outputs, even though we have the same information system being used. So in the reading, there is a very clear summary which just highlights the important parts of this chapter. And you can read further on this chapter by looking at part 1, chapter 3, pages 22 to 31 of our Coera reading, The Guide to Health Informatics.